This is RD Sharma's solution. We are taking class 12th probability and the exercise is the fourth exercise. A bag contained 3 red and 2 red balls. So let's assume that there is a bag and we assume that there are 3 red. So I'm just writing R1, R2, R3 to represent the red balls and B1 and B2 to represent the black balls. One ball is drawn from it at random. The ball is drawn and the color is noted. Then it is put back. That means there is replacement. The second draw is made and the same procedure is repeated. Again, a ball is taken out, the color is noted and it's being put back. Find the probability of drawing 2 red balls, 2 black balls, first red and the second black ball. Now the main key of this question is to make the sample space. If you make the sample space properly, the first, second and third probability being asked can be easily drawn out of it. One thing needs to be remembered here, that replacement is there. So the sample space, I'll tell you the key or the trick to write this, because there will be several combinations. You cannot make all the combination easily. So what we do is R1 write 5 times because there are 5 elements in here. 3 red and 2 black counts to 5 of them. Now once you have written R1 in a column, then combine it with all others like R1, R2, R3, B1, B2. So the first one can be red first ball. The other one can be any of it because the replacement is guaranteed here. Now this is the only first one. Second one, you will write R2. That is R2 can be the first ball. So I'm writing R2 5 times in a column. And the next one, the second ball along with this column R2 can be any of it. It can be R1, R2. That means all of the elements should be written here. R1, R2, R3, then B1 and B2. Then we have the R3. Again R3 in the this column followed by all other elements. Similarly B1 and B2, that is B1 as the first ball being drawn and the color comes out to be the black one, the second black one. And once you make this combination, let me reiterate that the sample space will give you all the probabilities easily. Now the third column we were, so R3 combined with all other elements from R1 till B2. Similarly, I'm writing all of it because the black and R has to be combined. So these are all the possible combination which are possible. So you can assume that these are all the possibilities that can come up. So there are 1, 2, 3, 4, 5 rows and 5 columns, and these 5 rows and 5 columns represent all the possibilities when first ball is drawn and then the second ball is drawn with replacement. So these are 5 columns, 5 rows. So in a sample space, number of elements are counted by number of rows multiplied by number of columns. So 5 rows and 5 columns. So number of elements in the sample space will be 5 multiplied by 5, and 5 multiplied by 5 is nothing but 25. So this becomes 25 now. Now the first probability, 2 red balls. So either of them can be R1, R2, doesn't matter because both are identical. We assume it to be identical. So 2 red balls means the sample space will be 25. It will be the denominator. Now take all of the elements in this sample space which has R and R. It can be R1, R2, it can be R2, R1 like that. So if you see this, R1, R1, R2, R1, R3, R1, R1, R2, 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 R3, R2, R1, R3, R2, R3, R3, R3. All of these are red ball in tandem. First red ball, the second also comes out to be the red ball. So this boundary which I have just made represent 9 numbers of element. So 9 by 25 is the probability of 2 red balls. The second one is saying 2 black balls. So B1, B2 should come or B2, B1 should come. Likewise all the combination where BB you find out. So probability of getting 2 black balls, of course the denominator will be 25 because probability is favorable cases divided by total number of cases. Total number of cases are 25. Now just find B1, B2, BB, not 1, 2, BB, wherever you find it out. So this one, B1, B1. So just see the right lower corner, and this periphery which I am making right now represent first and second ball as black balls in any order. So 4 by 25 is the probability. Third one. So now you understood why the sample space is so important in this kind of questions. First red and the second black ball. So it can be red black, black red in any kind of combination. We have already taken out the R, taken out the BB. Now you have to find out either RB or BR. So this one, this is red black, red black, red black. Alright, okay. But it has to be first red and second black. So we can only follow red and black. RB. You will be arguing why we are not taking black and red. It is being said specifically that the first should be red and the second should be black ball. That's why we can only take this, the boundary which I made. So it has to be again first red always and second black. 25 is the total number of cases and the boundary which I made represent the first red and the second black. So number of favorable cases are how many? 6. 6 by 25 is result. Now how it will be done? In this I have not showed the sample space, but it's very important. 3 cards are drawn with replacement from a well shuffled pack of cards or deck of cards. There are 52 cards. Let me show you and reiterate again. There are 52 cards, 26 of them black, 26 of them red. In all these 52 cards, there will be 4 suites. 2 of black, 2 of red. The 2 blacks are spade and club. The 2 reds are diamond and heart. Every suite has its own jack, queen and king and an ace. We have to find out the probability of king, queen and jack. So the first card being drawn, then you replace it. You put it back. Similarly, you do it with the second and third card. The first card can be any card. Second card will be independent of the first card because the replacement has been done. So in 52 cards, you are picking up and putting it back or depositing it back in the deck of cards. So the probability of getting a king and queen and jack, and since these 3 are independent, we write it as PK multiplied by PQ multiplied by PJ. K king, Q queen, J represents jack. So first king, queen and jack. The order is not being specified, so it can be king, queen, jack. It can be queen, jack, king. So there can be multiple combination or say permutation of all these 3 because they have not told specifically it has to be king at the first draw, queen at the second draw and jack at the third draw. So there are 3 cards which can be arranged in certain way. So 3 cards can be arranged in 3 ways in 3p3 manner. So one thing you can do is what I've done. K, Q, J, Q, J, K, all these kind of thing you can do. You know already how to do it. But the better way is to just say 3p3. NPR is factorial n by factorial n minus r. And factorial n by factorial r is what? It's factorial 3 by 3 minus 3. So it will be factorial 3 only. And this factorial 3 is 3 into 2 into 1. 3 2s are 6. So king, queen and jack. So you need to multiply this with factorial 3 because these 3 cards can come up in any order. How many orders are there? Factorial 3. What is the probability of getting a king, queen and jack? They all are same because there are 4 king. In all there are 52 cards. Again queen. In all there are 52 cards that goes in the denominator, but there are only 4 queens which can come up. So these cards which I am representing right now or rounding right now, these are just the king, queen, jack of different suites, but they count to 4 each of them. Again, there are 4 jacks. There are in all 52 cards, so 4 by 52. Factorial 3 is what? Factorial 3. N factorial is n into n minus 1 into n minus 2, like that. It goes up to 1. So 3 into 2 into 1. 4 by 52 counts to 1 by 13 if you simplify it. Now put this in this equation. Call it as equation number 1. So I am putting all these values in equation number 1. What is the probability now? PK is 1 by 13. PQ is 1 by 13. PJ for jack is 1 by 13. And their arrangement is 6. Factorial 3 is 6. When you multiply it, you'll get 6 divided by 2197. 13 multiplied by 13 multiplied by 13 is 2197. So this is how you are going to write it. It was a good question. The arrangement is also needs to be included. I hope 4 by 52 multiplied 3 times is okay with you. But this 3p3 has to be added. That is a new thing which you should learn from this question. An article manufactured by a company consists of two parts, X and Y. So an article, there are two parts being employed or used, X and Y. In the process of manufacture of part X, 9 out of 100 parts may be defective. So we'll start with the defective probability. 5 out of 100 are likely to be defective in the manufacture of part Y. So there may be 5 of Y which are defective. But the article is made with a combination of X and Y. You combine these two, then the article is made. So we have to calculate the probability that the assembled product will not be defective. We are making the set or the probability for X is defective, which we are calling it as A. We are calling B as Y is defective. So probability of A, this is given in the question, 9 out of 100, that is 9 divided by 100. It's already given. Probability of B, which is 5 out of 100. 5 out of 100 is simply 5 divided by 100. So this is likely to be defective in the manufacture of part Y. Now calculate the probability that the assembled product X and Y are to be combined, and that assembled product is called an article here. Now X and Y, we are taking X to be defective A, Y defective B, like that. When both are defective, or you can say A not defective is A naught, B not defective is B naught. So we have to find out the probability of P A naught intersection B naught. So all this means the product should come out to be defective. Not defective means we have to take the bar. We have to take the complement. So PA complement is, it's not defective. PB is not defective. Okay. X and Y both are independent articles. So you can just combine or find out the probability by multiplying the separate probability of PA naught multiplied by PB naught. So being defective is given in the question. Not being defective is what we need to find out. So not being defective is 1 minus of that probability. So PA plus PA bar is 1. This PA bar is 1 minus PA. That is not being defective. Because it's already given defective, right? So 1 minus PA represent not defective. So 1 minus PA. PA is defective, which is 9 by 100. 1 minus PB. PB is 5 by 100 is defective. 5 out of 100 are defective. So I am subtracting it from 1 to get not defective. When you multiply both these non-defectives, will get the probability of the product being not defective. So 91 by 100 comes out of 1 minus 9 by 100. 95 by 100 comes out from 1 minus 5 by 100. When you multiply these two, this is going to be 0.8645. 91 into 95 divided by 10000. This is your probability. Now this is how it needs to be done. We have to start with defective to being non-defective. The probability that A hits in a target is 1 by 3 and the probability that B hits it is 2 by 5. What is the probability that the target will be hit if each one of A and B shoots at the target? Wherever we have A and B, we normally assume that it is intersection. Wherever A or B comes, we normally assume that it is A union B. Let's see what comes up in this question. Probability of A, that is A hits the target, and this A hits the target is 1 by 3. It is already given in the question. I'm not writing anything extra. Whatever is given in the question, I'm writing that PB. If B hits target, that B is representing that B hits the target. And that is given already in the question, which is 2 by 5. 2 divided by 5 and 1 by 3 are respectively B hits target and A hits target. We have to find out if each one of A and B shoots at the target. Now you have to see this word, if each of one A and B. Each means A or B. I hope you have got the idea. A and B always represent that intersection. But here, this and A and B is preceded by the sentence or the phrase, if each one, either A or B. So this is a question of finding A or B. That is, we are talking about A union B. Each one of A and B shoots at the target. That is, either A or B shoots at the target. I hope you got the idea. This question seems to be A intersection B, but it's not. It's A union B. So probability of A union B has to be computed. A union B is quite known to us. This equation PA plus PB minus PA intersection B. But this PA intersection B, the A hitting the target and B hitting the target are two separate events. They don't have anything in common. They are independent. So when they are independent, you can write PA multiplied by PB in place of PA intersection B. So let's write this PA into PB. Now let's change here PA to 1 by 3, PB to 2 by 5, and PA to PB is 1 by 3 multiplied by 2 by 5. This can be computed. I know this is quite easy for you. It will be 3 by 5. This is A union B. 3 by 5 will come as the answer. So this is how it will be done. Target will be hit by either A or B. A and B points at intersection, but if each one of A and B, that means you're talking about the either A or B. So we are going with PA union B, alright? Because PA intersection B will be simply 1 by 3 into 2 by 5. An anti-aircraft gun can take away maximum 4 shots. Moving away from it, an enemy plane. The probabilities of hitting the plane at the first, second and third shot are 0.4, 0.3, 0.2 and 0.1 respectively. What is the probability that the gun hits the plane? Now at the first go, this question seems to be quite easy. The probability of hitting the plane is already given. 4 shots. What is the probability that the gun hits the plane? So we have a plane. There is an anti-aircraft gun. First time shot 0.4, second time 0.3, third time 0.2 and the final time is 0.1. Now whether it hits or not, so probability of hit is what? It's PA first time. Let's call it as 1. Probability of hitting second time PB. Probability of third time third. Probability of D, which is the fourth time. Now probability of A is 0.4. Probability of B is 0.3. C is 0.2 and final is 0.1. When you multiply this, you are going to get a value. Okay, 4 is a 12, 12 is a 24. It will be some 0.024. This is a wrong approach. This is a not wrong approach. We will find out the probability of not hitting. What is the probability that it doesn't hit? So what is the probability of not hitting? 1 minus 0.4. That is 1 minus PA. That first hit misses. The second hit misses. 1 minus 0.3. 1 minus PB. Then comes 1 minus PC, which is 1 minus 0.2, 1 minus PC. And finally, these are 4 different possibilities of first, second, third, fourth not being hit. 1 minus 0.1, 1 minus PD. So not hitting. 1 minus 0.4 is 0.6, 1 minus 0.3 is 0.7, 1 minus 0.2 is 0.8 and 1 minus 0.1 is 0.9. So this is the probability of target, which is the enemy plane, is not hit by anti-aircraft gun, is this value PH naught we are taking. So 0.3024, if you multiply this is going to come. Now coming to what is the probability that the gun hits the plane, PH plus PH bar is 1. Hitting, not hitting, add up together, it will be 1. We have to find out the probability of getting hit. The enemy plane getting hit is PH, which is 1 minus PH bar. PH bar we have already found out by multiplying all these probabilities just now. 1 minus PA, 1 minus PB, 1 minus PC, 1 minus PD. So when we multiplied this, we got all the probability of the enemy plane not getting hit. So 1 minus PH bar, 1 minus not getting hit is getting hit. So 0.6976 is the probability of the target getting hit. Okay, this is the correct approach. So this approach, which is very obvious, everyone will do like this, most of them including me. This approach is not correct. We have to think about some other thing, because 0.4, 0.3, 0.2, 0.1 multiplied, it will give you what? It is going to give you 0.024. Is this the probability when you have the probability of hitting 0.4, 0.3, 0.2, 0.1? This is very default that it cannot be that probability. So you have to find out some other approach. From here, it's quite obvious that the approach is not correct. That's why we applied the different approach that gives you the perfect result. So this is how this will be done. I hope this concept is clear to you now. Alright. This question will be taken in the next discussion. Till then, thank you so much. Have a good one.